Okay, in this video, we're going to try to solve this question, which is the same question as in the previous video, but we'll try to set up the work in one big long equation instead of doing separate stepwise fashion. Okay, hopefully this will be helpful for you to work on the homework assignments on my courses. Now, it's going to be exact same question, so if you want compare with what we're doing here in this video with the one on the previous video, hopefully it will be more helpful for you to understand why or how we're going to set up this work. Now, this question is about we have a sulfuric acid, which is unknown compound, okay, which is what the question is asking for. What is the concentration of sulfuric acid? And the known compound here is the ammonium hydroxide. You know the volume and the molarity. Okay, I can't overaddress this in titration problem, or which is another kind of stoichiometric problem. Okay, you're given the volume, but it's missing the concentration. Okay, whereas ammonium hydroxide, you do have the volume and the molarity, which is the concentration. That considered to be a known compound. So ammonium hydroxide is your compound A, and what you're trying to find out is the molarity of sulfuric acid. Now, typically, we're trying to find out the mole of compound A first, and then find out the mole of compound B second, and then find out the molarity of compound B. Now, we're going to start doing this by having both by the volume first, usually 23.18 milliliters. We have to understand that mole of compound A, which is ammonium hydroxide, should be multiplied the volume by the molarity, just as a reference. Okay, the mole in a solution, molarity calculation, mole equals to molarity times liter. Now, we do have the molarity, but we do not have the liter. So we first will have to convert this milliliters of ammonium hydroxide into liters by having 1,000 ml at the bottom, 1 liter on top. This is the conversion between liters and milliliters. Now, I do want to, especially in a big long equation, okay, I do want to keep labeling each number with the compound formula so I know what compound I'm working with. So this converting the milliliters to liters and multiply by molarity, okay, times molarity, which is 2.63. Now, usually we just multiply this, okay, but here, in order to better show you how this long equation is set up, I want to write this molarity or any molarity, okay, in a different form. I want to write this as this. The molarity basically means 2.63 mole of the compound, which is ammonium hydroxide, per 1 liter solution. That's the definition of molarity. Okay, so let me highlight this. Okay, the big M here stands for mole of the compound per 1 liter, and then of course you can have whatever number you're given in the front. So in this setup, I want to write this molarity as a conversion factor, having 2.63 mole ammonium hydroxide on top and the liter at the bottom. The reason I want to do this is because I know what I'm trying to find out first is the mole. So the mole of compound A is here. I mean, as the unit, okay, so on the top. And what I'm trying to get rid of here, you already got rid of milliliters. Now next is you want to get rid of liters. So this is essentially why we multiply the volume in liters by molarity. It's always going to give you the mole of the compound. Okay, now keep this in mind, okay, we're going to continue to set up this work. Once you have the compound A, so far this is liters times molarity. This gives you mole of compound A. Now, second step is going to be just like any other stoichiometric calculation. You're going to find the mole of B from mole of A using the coefficient ratio, which is 1, 2 in this case. Okay, but be careful which compound goes first. The mole of ammonium hydroxide should be cancelled here by having another one of it at the bottom. And of course, mole of B, which is sulfuric acid, is going to be on top. Okay, now it's a little bit lagging. Now the mole ratio here is just follow the coefficient on top, okay? 2 molar of sulfuric acid every 1 molar of ammonium hydroxide. Okay, now by crossing all the units out, this gets you the mole of sulfuric acid. Now typically, if you need to find what is the concentration, which is molarity, okay, you need to take the mole, divide by the liters, or volume, okay? So we already have the mole of sulfuric acid. The next step is going to be, I'm going to have the volume at the bottom. Now this volume, you're directly given a volume of sulfuric acid, 35 ml. The only reason I'm doing this is because I know I need to divide by the volume. So there's nothing on top really. Okay, this is not a conversion. This is just taking the volume mole again, divide by the volume. But unfortunately, this volume is in milliliters. I want volume in liters. So another unit conversion occurs here. By converting this milliliters into liters, but keep in mind, this milliliters can be only cancelled by having milliliters in the next item on top. Whereas liters is going to be at the bottom. Now let me highlight all the units we have worked out so far, okay? We convert milliliters by divide by 1,000 here, okay? So we convert first milliliters into liters, and the liters will be converted into mole of first compound by having the molarity here. And there's a mole to mole conversion using coefficient ratio. And then the mole divided by volume, which is in milliliters first, and then this milliliter will be converted into liter in the last step. And be careful here, it's going to be every 1 liter is a 1,000 milliliter. Now after crossing out all of the units that can be crossed out, the only units left over is going to be mole of sulfuric acid per liter, which is basically molarity. Now I know this looks longer than usual, but think about this. The reason it seems to be a little bit longer is because this whole work includes 2 liters, milliliters to liter, milliliter to liter conversion. Okay. And again, if you take a look at each step of what we have done here, the first step here is finding the mole of the ammonium hydroxide. Second part is finding the mole of sulfuric acid. The third step is taking the mole divided by the volume in liters specifically to find the molarity of sulfuric acid. So the answer will be exactly the same as the previous video. But also, when you set up this kind of long equation, keep eye on the numbers you have used, which ones you have to count the sig figs, such as the volume. Also the molarity. Any converting factors like 1,000 or coefficient ratio are considered to be exact numbers. No need to do the sig figures counting. So the final answer here should be having 3 sig figs. But anyway, this is how you set up a long equation. I hope this will help you understanding the process of setting up titration as well as any other stoichiometric problem.